So last time we were doing mathematical operations on K. K is equilibrium constant. Mathematical operation means if there is a reaction A in equilibrium with B, the K expression for this is concentration of B over concentration of A. If the value is 10, if I reverse the equation, what happens? If I reverse the equation, because these can be multiple choice questions, then what is the value of K? It is for the reverse, Sanjana, reverse equation, this one. Then it will be concentration of A over concentration of B. The value will be 1 over 10. Yes. Arya, you're getting it? And if I multiply the equation by any coefficient, 2A is in equilibrium with 2B. So what I did, I multiply this equation by a coefficient 2. So expression will be B squared over A squared. Value will be 10 squared, isn't it? So in that case, you have your new K value, K raised to power 2. So these rules are written in my notes also. You can check the notes. And if I add two equations, A is in equilibrium with B. This is where we left last time. B is in equilibrium with C. I want to add these two equations. Then B and B cancelled. Then A is in equilibrium with C. Let's say this is K1. Let's say this is K2. Write the expression for K1. Concentration of B over concentration of A. Sanjana, K2 is concentration of C over concentration of B. So what's the K expression for this equilibrium? Isn't it concentration of C over concentration of A? Can I get this expression by multiplying these two? Multiply these two. Multiply. When you multiply, B and B cancelled. See, I'm multiplying. Concentration of B over concentration of A. This is K1 times concentration of C over concentration of B. This is K2. Now you multiply them. B and B cancelled. So what are you getting? You are getting this K. But what is this? What is this? K1. What is this? K2. So when you add two equations, then their equilibrium constants will get multiplied. So we left here at this question, which is a moderate, means this is the level of the question. So it's not a tough question, but it's a very important question. And I'm going to teach you one more important concept here. So gear up for this question. Ready? Okay. So H2S is in equilibrium with, you're going to write on the equations. You remove first hydrogen. So what is formed? Remove first hydrogen, H plus and HS minus. Let's say this is K1. It's an acid. So acid, they donate H plus. So this is how they are going to behave in water. This is how they are going to behave in water. Now you take this HS minus and remove another hydrogen. You can see that they have given you two values. This we can take as Ka1, the removal of first hydrogen. This we can take it as Ka2. So this is Ka1 and now I'm writing Ka2, removal of second hydrogen. Is it clear what I'm doing? So from this Ka1, Ka2, I'm converting them into equations. Now, can you complete this part? Yes, can you complete it? Ashwin, remove a proton, remove one hydrogen. When you remove one hydrogen, H plus is out. We are talking about as acid. Yes, Sanjana. And then what is left? S2 minus. Aslisha is not there in the class. Yeah, she's there. Okay, answer questions. All of you, please try to answer, okay? Because I will be moving slightly faster, not very fast, slightly faster. So I won't be able to wait for a long time here because we have to do the review. I want to teach you everything in very less time. Okay, so we have Ka1, Ka2. So how many protons are there in H2S? How many protons? Protons, you know that H plus, how many? How many protons? Two. We call it as diprotic acid. Diprotic acid. So we have monoprotic acid like HCl. What kind of acid is this? Monoprotic. Monoprotic. We just write spelling. We are not going to write O here. Monoprotic. And then we have S3PO4. S3PO4 is triprotic acid. We are doing review of unit 7 and 8, Lisa. Unit 9, we are going to take extra class for that on coming Saturday. So children, those who are from regular group tutoring, and even if those who are new, if they want, they can join it. Saturday, I will put it on the WhatsApp. Saturday morning, I request all of you to make yourself available for Unit 9 last part. Remember, we were doing Nernst equation. I have to stop that because the time for review classes started. So that's why I stopped that, and I need extra class of nearly 2 to 3 hours to complete whatever is left of the Unit 9. Nernst equation, and then I think I have to teach you some batteries and electrolytic cell. Three things are left. Nernst equation, I gave you the concept in the previous class. Nernst equation. Second, electrolytic cell. Third, your batteries, different types of batteries. Batteries are not going to take much time, but they are very interesting, and you'll find them learning about them. Very interesting concept because you are dealing with batteries every day. You are using batteries. So these are the three concepts which I want to do in Saturday morning extra class. Those who cannot join, please watch the video after the class. I will post the video there and you can watch the video. And those who are interested, new students of review group, if you are interested, you can also join. Okay, so back to the learning part. So I just answered a thing, what Lisa was asking. So please do not ask thing in the private chat. Then other students, they just don't know what I'm talking about. Okay, so please do not ask anything in the private chat. And Zara, can you put it in the journal chat what you are asking? She is asking the time. The time will be 10 a.m. EST. It will be 7 a.m. PST, and it will be 8 a.m. not 8, 9, 9 a.m. CST. So accordingly, you can see the Zoom link over there and you can join from there. Shall we continue? Okay. So I was telling you about the monoprotic, diprotic, and triprotic acids. Diprotic when there are two hydrogen, monoprotic when there is only one hydrogen, triprotic if there are three hydrogens. Triprotic, three hydrogens. Like here, you can talk about for the monoprotic acid, for example, HF is a monoprotic acid. So when it's going to dissociate, it will give you H plus and children F minus. And it has only one equilibrium constant value Ka, only one, because there is only one proton. But if I take H2S, then you can see two equations, which I have written here, Ka1, Ka2, two of them. And if I take a triprotic acid, now all of you are going to help me in triprotic acid. S3PO4 is a triprotic acid. There are three hydrogens. Can you remove the first hydrogen, children? Remove the first hydrogen. Mhm. Remove the first hydrogen. We are learning a concept. We are learning different types of acids, monoprotic, diprotic, triprotic. Yes, Sanvi, very good. H2PO4, 1 minus. And then one hydrogen is out. Okay. The equilibrium constant for this one, I'm going to call it as Ka1. Now I'm giving you another, this acid, this one. This is also an acid. Remove another hydrogen from here. Remove another hydrogen. Yes, please. Remove another hydrogen. Ashwin, Ritika. The charge will increase because you are removing H plus. So the negative charge, whatever number of H plus you will remove, that much number of negative charge you have to answer. Lisa, you are still in the direct message. Can you change the option there? Just make it general. Your answers are not visible to all of us. Okay, and if I want to remove the third, and I want all of you to write down the equation. Remove 1 H plus, add 1 minus on the conjugate base. Okay, acid to conjugate base, you are removing H plus, adding, after removing H plus, you are adding 1 minus. Who are the children who are finding it difficult to understand, they can write this hint. So when I remove H plus, then I will get one extra minus on the conjugate base. So you can memorize it like this. 1 H plus, 1 minus left on the conjugate base. Right? Now this is Ka1, this is Ka2, and this is Ka3. Now let's come back on this question again. Can you look at the Ka1 value and Ka2 values? Ka1 and Ka2. Please, children, when you are making notes during the class, you have to leave gaps. Okay, because sometime I start writing, I can erase and I can create space for writing again, but you won't be able to erase. So you are going to just like you are writing this equation, keep some gap every time, whatever you're writing, some gap, so that if I come back and write something, you can add over there. So leave some gaps. Like I've given you this concept, you can put it as a trick or a shortcut or to memorize. So I will be giving you plenty of tricks during the class. So shall I erase it now? I need some space. Okay, now we are focusing on another concept. We have understood triprotic, diprotic, monoprotic. Now we are on another concept. Compare the value of Ka1 and Ka2. Which value is greater? Is given here. Which value is greater? So you can plug in the values here next to the equation. Ka1 1.00 times 10 raised to power minus 7. Ka2 1.00 times 10 raised to power minus 19. Can you see, children? No units. Who is going to tell me why there are no units for Ka1 and Ka2? No units. Why? Because they are equilibrium constant. Yes. These are equilibrium constant. They have a name here now. Ka means, what's the meaning of A? Acid. This is dissociation constant of an acid. That's why Ka. So equilibrium constants, they have different names. This is the first name you're learning. I think you already done Kc and Kp. You already know the meaning of these two. Can you see how they are getting names? You will do KSP, you will do KB, you will do KW, all these things. So now equilibrium constants are getting names. So these are equilibrium constant. That's why no units. Which value is greater, Ka1 or Ka2? Mm-hmm. Answer fast. You can compare the values. Values are given there. Ka1 is greater than Ka2. This is a multiple choice question. Multiple choice question. Why? Or sometime just you have to see which one is going to be greater. But my question is why? The same thing you will observe here. The same thing. Ka1 is greater than Ka2 and Ka3 will be very small. And again, they will ask why, or they will ask the order. Sanvi is saying Ka1 products are more favorable. Yeah, she's right. You'll get slightly more products, but still they are not favorable. Sanvi, are they favorable? Is this dissociation spontaneous? Are they favorable? Are you getting plenty of product? Okay, but yes, you are right. You can say more than this one, right? So you can say that. That's not a bad answer. Okay, Sanvi, it's a good thing. She's saying here there are more products, here there are less products. Question is why. So please understand this why. I'm giving you answer of this why. It's an explanation. So don't get distracted. Write down in brief points. Listen to me. It's very easy to understand. It's a very popular question. I've seen many times. Now, what is the charge on this H2S? Zero. So you are pulling out H plus. What are you pulling out? H plus from this zero charge. What's the charge on HS minus? Minus 1, and you are pulling out H plus. In which case, the H plus pulling out is easier when the charge is 0 and when it has a minus 1 charge. You know, minus plus, they attract each other very strongly, isn't it? Who is holding this H plus more tightly? H2S or HS minus? Who is holding hydrogen more tightly? Plus minus? Think about plus minus attraction. So in which case the H plus is very strongly attracted. Isn't it in this case? Yes. This one is holding it more tightly because of the negative charge on it. And you will find to take out this H plus more difficult. So you can write down in brief, it is more difficult. I'm writing here. It is more difficult to pull out H plus from negatively charged species, negatively charged ions, you can say, because of, yeah, what should be the answer? Because of more attraction. Somebody who is negative charge will not let the positive to move out. Negative and positive are attracted to each other. It is more difficult to pull out H plus from negatively charged species or ions because of more attraction of plus and minus. More attraction means plus minus. Is it okay? And now answer my next question. I want all of you to answer. My next question is, which one is stronger acid? This is an acid, this is an acid. So this is an acid and this is an acid. Which one is stronger acid? Mhm. So compare their Ka values. Yes, Sanvi? Stronger acid. Which one is stronger? Azuni, is this the answer? HS minus? Okay, Azuni? Oh, no. Okay. So which one is stronger? H2S. Why? Because its Ka value is bigger. So it's going to give you more of H plus, more H plus. Reaction is slightly more in this direction. Whereas in this case, Ka2 value is so small, very small. See the difference. And the same thing will happen here. If somebody asks you to put them in the order of stronger acid to weaker acid in this order, then which one is the strongest here? You can see the order of Ka values. Ka1 more than Ka2. Why? Because in Ka1, you are pulling out hydrogen from zero charged species. Here, you are pulling out hydrogen from -1. Here, you are pulling out hydrogen from -2. It's more difficult to take out hydrogen from -2, right? Because more negative, more difficult to take out hydrogen. So which one is the strongest? H3. These type of questions are there in multiple choice. H3PO4. Then which one is the next? H2PO4 minus. Then which one is the next? HSO H sorry HPO4 2 minus. Do you think PO4 3 minus is an acid? Do you think it can work like an acid? PO4 3 minus. Can it work like an acid? Yes or no? Is it going to work like an acid, children? PO4 3 minus. Yes, Sanvi. Aslisha, your answers are not coming. Ariba, Anil, is he in the class? I saw him in the class. Okay. No, it's not an acid. Yes, Anjara, very good, Afan. So then why it is so? Why it cannot be an acid? Because there is no H plus. It cannot donate hydrogen. Then what is it? If it is not an acid, what is it, children? The base. It is a base. It can take H plus because of the negative charge. So it's a base. So we are going to do definitions again, acid-base definition. Right now, we are focusing on mathematical operation. And then we started doing this last question on this mathematical operation. You are looking at the question. So you will look at the question and you will write down the equation the way I have written like this. Okay, let me clear some space so that we can work now. You can see these two equations for Ka1 and Ka2. All of you are okay with the equation? You should be able to write them. Only then you can answer this question. Now, what are they asking? Look at what are they asking. They are asking, given the information here, which of the following value of for this acid, this one, for this equation, what should be the value? So H2S is in equilibrium with 2H plus S2 minus. How to get the equilibrium constant, the Ka value for this reaction? So how can I get this reaction, children? By adding these two equations. Add them. See, cancelled. HS minus here is the product. I'm adding these two equations. When I add these two equations, I'm getting exactly this equation. Yes, Sanjana. So it means the Ka is Ka1 times Ka2. So what's the value? 1.00 times 10 raised to the minus 7 times 1.00 times 10 raised to the minus 19, and answer is 1.00 times 10 raised to the minus, yes, 26, isn't it? I think I'm right. You're going to add these exponentials. Just add them. Okay, so that's about the mathematical operations on the equilibrium constant. And this is one of the very important type of question. Not exactly same question will come, but type of question. And here I told you about the monoprotic, diprotic, and triprotic acid. Okay, I'm giving you one more example. H3ESO4. Okay, let's take another one, not this one. H2SO4. What kind of acid is this? Monoprotic, diprotic, or triprotic? Monoprotic, diprotic, triprotic. Diprotic. Okay. So when you remove remove first hydrogen. So what is the conjugate base? I gave you the trick. Remove hydrogen, subtract hydrogen, and whatever left, put a negative charge on it, one negative. You remove first hydrogen, one negative, because you're starting from zero. No, Ritika, remove first hydrogen, right? Ritika, you're understanding? Okay, then now remove second hydrogen. Afan, remove second hydrogen. Now all of you are going to answer. There is already one minus. Sanjana, your charge is wrong. There is already one minus and you are removing one H plus. So don't you think that remove one H plus, add one more minus? So charge is SO4 2 minus. Yes, Lisa, very good. Yes, Lisha, you are there? You're not responding here. Oh, okay. Are you answering, dear? I cannot see your name. Keep answering. Okay. So we are good with this. Now, can you see here? See the difference in the arrow? So in which reaction there is equilibrium? In the second. Is there equilibrium in the first? No. It means it's a strong acid. Strong acid. And this one is going to work like a weak acid. So again, this thing we have already done. So remember this, whenever you are dealing with a strong acid, there is no Ka values. There is no equilibrium. only you will get Ka value when you are dealing with a weak acid, and you will get a Ka for this part, which will be less than 1. And the Ka for this one will be large, more than 1. Large is fully dissociated, is totally on the product side. Okay, so these are some important concepts. Now we are moving on to the next one here. This is a question on what we have just done. I want to calculate K for this reaction. So first, you can see that how to get this reaction. How to get the reaction? How can I get the reaction? If I add them, am I getting the reaction? Add them. What all is cancelled out? CuX, CuX, CuX2 minus, CuX2 minus. They are cancelled, right? Am I left with this equation? See, 1 Cu plus and 3x minus on the reactant side and CuX32 minus on the product side. So I added the equation. So what is the K value then? When you add equations, reactions, the new K is the product of the equilibrium constant of every reaction which you have added. So answer will be 1.0 times, add these exponentials, 10 raised to power 9, no units. So this is one type of multiple choice question which can be in the exam. Shall I erase it now? Moving on, children. Lee Chatelier principle, we already started discussing about it. But now I'm going to tell you a few important things. Question can be in any format, okay? It can be, it's not that what you have learned from me or from your teacher in the school. They may twist the question because that's what they are doing. They may twist the question in entirely new scenario kind of thing. But you can still answer it. Why? Because if you are very clear about the concept, you are very clear what is happening, then whatever scenario they will give you, you can answer the question. Here, Lee Chatelier principle you already know is the shifting of the equilibrium in the direction to nullify the change. So what happens that there is an equilibrium. You can see here. This is initial equilibrium. There is a system perfectly in equilibrium, perfectly stable, perfectly with the lowest energy. And all of a sudden, in that equilibrium, you added ammonia. Can you see? All of a sudden, this part. This is sudden addition. As you added ammonia, you know the equilibrium constant? It is the, yeah, please write down in your notebook. You are doing review and you are memorizing also, practicing also. Don't expect that, okay, I'll sit someday and do it. That someday has come. So keep writing in your notebook. Whatever I'm asking, whatever I'm saying, you also write in your notebook and see whether your writing is correct or not. Compare it with my answer. And you should have your calculator next to you. NH32 over concentration of N2, concentration of H2 raised to power 3. Now, all of a sudden, you added ammonia. So, what you have increased? You have increased ammonia. So, what happens to the value? It increases because ammonia is in the numerator. So, is this K now? No, K is a constant, right? K cannot be changed. Who can change K, children? Only one factor can change K. Who can change temperature? Very good, Sanvi. So, good, Lisa. So, as I'm increasing this K, then all of a sudden the system is in non-equilibrium state and now it is not K. What is it? Q. And this Q because you increase ammonia, so this Q definitely greater than K. So Q greater than K means products are more. This is more. In which direction the equilibrium will shift? That's the Chatelier principle. Now equilibrium will shift to nullify this change, to come back to K. It will try to make Q K. So in which direction it will shift? Yes, all of you, please. It will shift to the left. We already know it, but still I already discussed it, but still I'm discussing it again because I want you to understand some other questions based on it. So what will happen to the concentration of ammonia? See here in the graph, what is happening? The concentration of ammonia when it is shifting to the left, decreasing. What is happening to the concentration of N2 and H2? If concentration of ammonia is decreasing 2 times, means let's say it is just random figures. Let's say it is 4 here, now it is 2. How many times the concentration of H2 will increase? Look at the balanced equation and answer it. Ammonia is decreasing by two times here. This decrease is by 2 times. By 2 factor. Okay? Factor of 2 decrease. So how many times this increase? I'm just trying to make you understand the mathematics also. Yes, Ashwin, 3 times. Look at this coefficient. A 2 time of decrease will increase this concentration 3 times. This will increase by 3 times, by a factor of 3. And how many times this will increase? So this can be a question. This is very mathematical question, right? Based on the balanced equation. Okay, I'm changing the question. Those who have not understood, please try to understand again. Changing it. If ammonia has decreased 6 times, how many times hydrogen has increased? Mhm. 9 times. Are you adding them? It's a factor, right? It's a factor. It has decreased by 6 times. So it should, if it decreases by 2 times, oh, okay, yeah. Then I think you're working like this. 6 times 3/2, like this. Yeah, 9 times. Perfect thinking, children. Perfect. Yes, Afan, come back fast. And what about N2? So can you see that I can use the ratio, those who are not able to visualize in this manner? So how many times ammonia has decreased? 6. That is ammonia. Then plug in the ratio, molar ratio. 3 hydrogen over 2 ammonia. This cancel. So hydrogen will increase 9 times. Those who have not understood this in this manner, it's for them. Okay, now what about the nitrogen? How many times the nitrogen will increase? You can use this ratio. Nitrogen will increase 3 times. Yes. So these can be the questions. These are not actually equilibrium questions. They are more of the question based on calculation of the moles and everything. Okay, great. Ready for questions? Before we go for the questions, write down some important point for this Le Chatelier principle. Solids, liquids, these you have to memorize or practice. Actually, not memorizing, practice. Solids, liquids, and inert gases in rigid containers This inert gas in rigid container. Rigid means, I told you the meaning of rigid container last time. Inert gases in rigid container cannot shift the equilibrium. Cannot shift the equilibrium. First thing is that this will help you in answering many questions. Second, if you increase concentration, it will shift to decrease it. If you increase concentration, the shift will be to decrease it. Shift to decrease it. So it will move in a direction to decrease it, to left or right, whatever concentration. Like here, you are increasing the concentration of ammonia. So it will shift to decrease the concentration. This is called as stress on the equilibrium. You know that you started with a perfect equilibrium, perfect stable form, and all of a sudden you added a stress. You added excess of ammonia, equilibrium has come under stress. Now it is no longer equilibrium, now it is Q. So that's why we call it as stress. So system is subjected to a stress. Now system under stress would like to go back to equilibrium and it will shift left and right accordingly whatever stress you have placed over there. It will try to nullify it. Third, if you decrease concentration, then it will shift to increase it. Shift to increase it. Like if I remove nitrogen gas, remove. I'm removing nitrogen gas. In which direction the equilibrium would like to shift? Mhm. Remove. In which direction? It will shift to the left to increase it. If I remove ammonia, then it will shift to the right to increase it. Okay. Then we have pressure. If you increase pressure of the system, complete system, it will go in the direction of low pressure. If you decrease pressure, then it will go in the direction of high pressure. How to identify low pressure and high pressure? You have to compare the moles on both the sides. Compare moles of gases. Don't try to take solids and liquids. Their pressure doesn't matter. Pressure is important only for gases. Compare moles of gases on both sides. On both sides. Then fifth, volume. But volume we already know is related to pressure. If you increase volume, what happens to pressure, children? Ideal gas law, Boyle's law, PV equals to nRT. Pressure will decrease. If pressure decreases, it will shift in the direction of high pressure. Yeah, fine, good. If I decrease volume, then what happens to pressure? If I decrease volume, what happens to pressure? Pressure will increase. And if pressure increases, equilibrium will shift in the direction of low pressure. This is your comparison of the volumes and pressure. What is the effect if you now look at this equilibrium? In which direction this equilibrium will shift? If I increase volume is increasing. volume is increasing. So as volume increases, pressure, pressure is decreasing. So you're doing this change. This is the stress. Now the system will try to nullify this stress by shifting in the direction of high pressure, high pressure. So it means you have to check which side has high pressure. For high and low pressure, you are going to check the moles on both the sides. Check the moles on this side. Check the moles on this side. Yes. Hmm. Which side has more number of moles? Sanjana. So which side has high pressure, Ritika? Which side has high pressure? Reactant side. More moles I've written here. I've given you a hint. Compare moles of gases on both sides. More moles means more pressure. More moles of gas means more pressure. So please write down this. So which side has more pressure? The left side. So when you increase the volume, pressure decreases, system is moving in the direction of high pressure. So it means the system will shift to, this particular system will shift to left. Shifting will be to left in the direction of high pressure. This is high pressure and this direction is low pressure. Azuni, is it okay? Okay, I'm asking a question. I want answer from all of you. All of you are going to answer this question. Volume is decreased. Volume of this system is decreasing. I have reduced the volume. I have moved down the piston. You know, you can increase and decrease the volume of a container by moving a piston up and down. So what I'm doing, there is equilibrium here of these gases, and all of a sudden, I reduce the volume. I applied force, and the piston has moved down, and volume is decreased. So when volume is decreased, what happens to pressure? Pressure increases. As pressure increases, in which direction your equilibrium would like to shift? In the direction of low pressure. Now check your system, this system has which direction with low pressure? Ashwin is right. It will shift to the right. Yes, Ritika. Aslisha, again, no answers. Afan, no answers. Arya, Anzara, Arya, you're understanding this? Lisa, Sanvi, all of you have understood this? This is very important. Okay, now I'm telling you one more about temperature. Temperature. See, this is 1, 2, 3, 4, 5. Now we are on the sixth. Temperature. If you increase temperature, it will change the value also. Okay, value will also get changed, but shifting will also take place. Both the things are happening here. If you increase temperature, the system will move away from heat. Whatever side heat is written, it will move in the other direction because high temperature means more heat. And I'm increasing temperature. So system wants to go away from heat. And if you decrease temperature, the system will move in the direction of heat. Move in the direction of heat. Is it okay? Okay. You have understood why? Because heat means temperature. If system is undergoing a stress of high temperature, it will try to go in the direction where the temperature can be brought down or temperature is less. Like for example, this reaction is exothermic. Exo. In which direction should I write heat? Is exothermic. Where should I write heat, children? Hmm. Where should I write? On the product side. On the product side. Very good. All of you are clear about it? Some students they get confused. Where should I write heat? Exo means heat is a product, one of the product. So this side has high heat, right? High temperature. If I increase the temperature of this system, in which direction the equilibrium will shift? Yes. In which direction, Ariba? If I increase, use this statement which I have given you here. If I increase the temperature of the system, the equilibrium will shift in the direction away from heat. Which side? Which side is away from heat? Yeah, use it. Use this language. It will go to left. If it is going to left, what happens to K value? You know, K concentration of ammonia raised to power 2 divided by these two raised and with their coefficients. And Sanvi is right. K will decrease because reactants are increasing, products are decreasing. You're understanding this, children? Okay. Now, if I decrease the temperature, if I decrease the temperature, in which direction it will shift? It will shift in the direction of heat. It will shift. Sanvi, where is heat? Look at the equation. Where is heat? Heat is here to the right side. You are decreasing temperature. It will go in the direction of heat. Low temperature means less heat. Then it will try to get more heat by going in the direction of heat. Sanvi, what about rest of you? Arya, is it okay? It will go in the direction of heat. Going in the direction of heat means to the right side here because heat is on the right side in exothermic. So what happens to K value when you decrease the temperature in exothermic reactions? What happens to K value? Yes. Arya, what will happen to K value? Your system is shifting in the direction of the products. K is the concentration of the products with the concentration of the reactant. K will increase. Yes, K will increase. These are the questions, children, very important. And the last factor is catalyst. Very popular again. Very widely asked every time, and they ask the reason also. With catalyst, no shifting. No shifting. Because there will be no change in the equilibrium status. And they say why? Why with the when we add a catalyst, nothing is happening to the equilibrium. So let's understand that, and that's a very important factor. So make brief notes about it. All hands in the notebook with the pen, and try to understand also. So first of all, when you add a catalyst in a reaction like this is a reaction. Here is the energy. What kind of reaction is this? Endo exo. This is the reactant. This is the product. Yes, Sanjana, good. Yes, it's endo. Arya, this is endo reaction. Ariba and Azara. Azuni. endo reaction. Okay, this is endo. When I add a catalyst, what happens? For unit 5, we did about catalyst in unit 5. The activation energy decreases. This is the effect of the catalyst. Is there any change in the energy of the reactant or product? No. Only activation energy is going down. This is with catalyst. With catalyst. And this is without catalyst. So these diagrams are, they are a lot there in the exam. So they can ask plenty of questions on it. Questions will be very simple. If you can understand the concept, retain them, then you will see AP exam is very simple. But concepts are very important. So with catalyst, without catalyst. So when is the rate of reaction faster? With catalyst or without catalyst? Rate of reaction. When? When is the rate of reaction faster? With catalyst. Why? Why the rate of reaction is faster with catalyst? Because activation energy is, no, that's the reason. Activation energy is less. More molecules can get this much energy to give the product. Effective collisions, unit 5, lower activation energy. Remember this, these are important things. If I'm repeating something again and again, it means it's very important. Activation energies are low, rate of reactions are faster. Now let's compare the rate of reaction, reactant to product, and then product to reactant. Don't you think that activation energy has gone down for both of them? Like earlier, reactant to product, the activation energy was this, but after adding catalyst, the activation energy is only this much. So reactant to product, activation energy has gone down. Now let's see the reverse, product to reactant. Earlier, product to reactant, the activation energy was this much, this much. After adding catalyst, the activation energy is this much. So don't you think the activation energy has been lowered in both the ways? The activation energy has lowered in both the ways. Oh, sorry. It means the rate of reaction, E activation, lowered in both directions. That's the reason. So, rate of the forward direction and rate of the reverse direction are equally increased. Whatever amount rate of the forward direction has increased, exactly same amount the reverse direction has increased. And if you remember my from the last lecture, that the equilibrium constant K is the rate of the rate constant of the forward direction over rate constant of the reverse direction. If you remember that, equilibrium constant, forward rate constant. But they are equally affected, so this ratio remains the same. So K remains the same. This ratio is not undergoing no change. No change. So K value is not undergoing any change. No change. No Q. You are not getting any Q here. No change means no shifting. No shifting. On the whiteboard, we have limited space, so that's why I'm keep changing the color. So whatever is written in the brown color, that is for starting from here. Effect of catalyst. Very important concept, and you'll be tested strongly for it, either in multiple choice question or in your free response. So ready for some questions now, children? We can do questions very fast. I'm going to clear it. Shall I clear it? Okay. Yes. Answer these questions and I want fast answers and from everyone. I'm not going to wait for anyone. Try to be faster than me. Read the question. This is an equilibrium. You can see equilibrium sign here. Gaseous carbon dioxide is removed. It will shift to the uh, uh, why? Azuni is right. It's removed. It's not added. Removed. You are decreasing it. If you are decreasing, it will shift in the direction to increase it. To fill in, yes. It will try to increase the amount of CO2. Okay, no problem. B. Water vapor. This one. It will shift to the right. C. Rigid container helium gas is added. Remember, I told you that inert gas added in a rigid container. No change. Yes, no change. Very good. D. Reaction is exothermic. Exothermic. Exothermic means heat is here on the product side. You are increasing the temperature. In which direction the system will go? It will move away from heat. So left. What happens to K value? What happens to K value? Yes, Afan. It will decrease because you are making more reactants. More reactants means K is less. More products means K is more. Okay. Pressure is increased by decreasing the volume. So as you decrease the volume, pressure increases. So the system will try to go in the direction of low pressure. Which side has low pressure? Check the moles. Two here, and Ritika is right because there is hardly any change in pressure. So no shifting, no change. Easy, children? Okay. Okay, let's do this one. This one is really interesting. And I want all of you to use your brains and answer this question. Look at this. Temperature increasing or decreasing? Temperature increasing. Look at the Kp value. Kp value increasing, decreasing. Kp value is decreasing. In which direction the equilibrium is shifting if Kp is decreasing? It is shifting to left. So where should heat be written? That's what they are asking. So where should I write heat? So that if I increase the temperature, it will shift to the left. Should I write it on the right side or left side? Okay, Ashwin, think about it. Heat should be written on the right side. Do you agree with this, children? Because only then it will shift to the left. So what is it? Endo exo? It is exothermic. Ashwin, you have understood this? And Zara, good. So that's about your Lee Chatelier principal questions. Now this is the real question in the examination and it's a combination of different things. So let's do it. Reaction, you can see this is real question. I don't know which year. I think 2022. So I picked up from the real exam paper. Can you look at the values here? These are the partial pressures of these gases at equilibrium. This is equilibrium mixture, this one. the partial pressure. Can you calculate Kp? Can you calculate Kp? So first you write down Kp expression. So what is Kp expression? Pressure of CO times, please write down in your notebook. Don't wait for me. There is no need of typing here in the chat. Just put it in your notebook and check whether you are right or wrong. You can answer simple questions in the chat. But for mathematical equations, complicated things where we have to work a lot or we have to type a lot, ignore it. Just do it in your notebook and compare your answer with my answer. And if you are not getting it properly, you are not understanding, then you can ask here in the chat. This is your Kp expression. And these are the equilibrium pressures. How will I come to know these are equilibrium pressure? Read the question carefully. And they are saying it's equilibrium mixture. You can see this line. If they are not saying equilibrium mixture, then it is Q, not K. But right now they have clearly indicated that it's an equilibrium mixture. So I can plug in the values. Plug in the values. Pressure of CO, these are partial pressures of these gases in the container. All these are present in a container, this container. Container is closed. Only then you can get the equilibrium. These gases are there, all of them. And the partial pressure of CO in this container is 4.2. Hydrogen is 8.4 squared divided by 2.7. Now I know mathematically you can calculate the answer. So there is no need, just leave it. And no units. No units. Such a simple question, right? Now G part. Can you answer this? The volume of the container is rapidly doubled. Doubled. The volume is doubled. So what will happen to pressure? The volume is doubled. What happens to pressure? Pressure will be halved. Very good. Will be halved. In which direction the equilibrium will shift? See, as equilibrium is going to re-establish, means now it has become Q. This is the stress which you have placed. There is no Kp. Now it becomes Qp. Pressure has decreased. In which direction the equilibrium will shift? So check here. Which side has more pressure? It will shift in the direction of high pressure, right? The pressure has decreased, so it will shift in the direction of high pressure. Look at the equilibrium. Which side has high pressure? Yes, Sanjana. So it will shift to the right. Right side has high pressure, children. 3 moles. It means you will get more amount of CO and H2. Right? So it will shift in the direction of high pressure to maintain the value of Kp. Is it okay? Okay. Now they are asking something else. This is the basic understanding. So as equilibrium, does the number of moles of CH3OH increases, decreases, or remain the same? So you already said that it's going to shift in this direction, right? So what is happening to the amount of CH3OH? It's decreasing. Okay. Justify your answer by comparing the value of reaction quotient. Okay. Now we said that everything is halved, correct? See, volume is doubled. Very good question, children. Pressure, volume is doubled. Pressure is halved. So what are the new pressures? This is going to be Q now. This is K. This is K. This is equilibrium mixture. Now, in the G part, I'm dealing with Q. So, what is the Q non-equilibrium state? It's not a equilibrium state. So, what is the pressure here of CH3OH? 2.7 divided by 2. 4.2 divided by 2. 8.4. Is it okay? So, now calculate Q. Q has the same expression. It is the concentration of H2 squared. Oh, now we are dealing with pressure. Pressure, right? We are working with QP. This is QP. This is KP. So it is pressure of H2, which is, you are saying is 4.2 squared. And CO is how much? 2.1 and 1.35. Get the value of Q. I think I need K now. You remember we didn't calculate K. Anyone can you help me in calculating K, which is 4.2 times 8.4 squared over 2.7. Can we work out this value? I'm getting this value 109.76. Which one you calculated, Azuni? This one? You calculated Q, Azuni? Isn't it K this, Azuni? Just check your calculation again. Because I think Anzara is also giving me this value for KP. And this one I'm getting, children, this one, the QP, I'm getting QP here as how much? Yeah, very good, Sanvi. I'm also getting same. No units, children. Sanjana. Now, which one is more, KP or QP? So can I say QP is less than KP? They're asking you to show all this as a free response. This is a free response question. So then in the F part here, you are calculating KP, this value. Then in the G part, you are going to say volume is doubled, pressure is halved. Then you are going to make this table. And then you are going to say that, okay, compare QP with KP. QP is less than KP, right? QP is less than KP. You have to show this part. You have to make this table. The new pressures of a non-equilibrium state, you can write here, non-equilibrium. Whatever way you feel that you have to convey your thinking to them. The one who is checking the paper in free response, they are they are trying to read your brain that are you understanding or you are just throwing something. So right here, non-equilibrium, QP. These are the pressures for QP. QP is less than KP. Then explain if QP is less than KP, it means reactants are more, product is less. So it will go in the direction of products. Direction of products. And which means to the right, which we already have understood that why it is shifting to right. We were already saying it will shift to the right. Why? Because we are decreasing pressure. So it will go in the direction of high pressure. Is it okay? Children, this question is a free response question from real AP exam. I hope everything is clear here. Let's see if we have more questions on it. Yeah. That's the last question on the Lee Chatelier principle. And I think it has covered everything, everything, all types. And I've given you the list, what you have to consider and what you can say no change. When can you say no change? And when you have to see that in which direction the equilibrium will shift. Now, the rice table. Rice tables, all of you know, there are plenty and plenty of questions which can be made on rice tables. In the rice table, first you are going to write down the reaction. Like this is the reaction. See? Then initial, change, equilibrium. To know initial, change, and equilibrium, you have to read the question carefully. From here, what is initial? Solid ammonium chloride was placed in evacuated container. Evacuated means there is nothing in it. So it means ammonia is zero and hydrochloric acid is zero. You know it. Ammonium chloride, I'm going to put a dash because it's a solid. So why should I place a dash here? Because in my Kp expression, the solid is not the part. It is the pressure of ammonia times pressure of HCl. I'm working with Kp because they are asking me to work in Kp. They're asking this, calculate Kp. You're understanding this? So I'm not working with Kc here, I'm working with Kp. And in that, I'm not going to take this solid. Solids, their concentrations are unity. I told you in the last class. Change. What is change, children? If I say change depends on these coefficients. If I say X amount of ammonium chloride has undergone dissociation, breakdown, then how much ammonia formed? X. How much HCl? X. And that equilibrium, now again, I'm not interested in this solid. I'm not interested. It's not the part here. At the equilibrium, how much ammonia? X. X. What are the units? What? This is the rice table in terms of pressures. And this is the equilibrium state. So what is the unit of X? X is pressure. And what is the unit? ATM. And why I'm taking ATM? Because they have given me the total pressure of the container. Total pressure of the container. See? After heating, once the system is in equilibrium, so this is the container. Container has to be closed. This is the solid ammonium chloride you added. And after equilibrium is achieved, then there is ammonia and there is HCl as gaseous molecules. And the P total, now I'm going to use Dalton's law of partial pressure. Remember, I was discussing in the last class also. It is the pressure of ammonia plus pressure of hydrochloric acid. But what is the pressure of ammonia? X. What is the pressure of hydrochloric acid? X. So can I say 4.4 ATM is X plus X? What's the value of X? 2.2 ATM. So what is my Kp? What is Kp? X times X, that is X squared. This is one example of the rice table in which we are using this concept also from unit 3, that the total pressure of the container is the sum of partial pressure of every gas. And then you can work out the value of X. Oh, sorry, you can plug in the value of X. Kp, they are asking Kp. And X we know. So we are working out Kp like this. Is it okay? Children, this rice table is clear? Anyone struggling here? If you are struggling, please ask your question. Anyone struggling with this table? This is a very important question. I want you to understand thoroughly and how we are using Dalton's law of partial pressure and calculating the x values. Ready for another question? Another question on rice table. Ready? Okay. So rice table means reaction. So let's write on the reaction. CO2, gas. By the time I'm writing the reaction, keep reading the question. We have to do plenty of work in very less time. We are not going to waste even a single minute. So this is the reaction. Initial, change, equilibrium. How will I come to know that I have to make rice table? The question is telling you. Right now, I'm doing rice table questions. So I know that we have to write the rice. Otherwise, you read the question. See, they're asking you to calculate the value of Kc. And what they have given you, 1 mole of CO2 is placed in 1 liter container allowed to come to equilibrium. So they initially what is there? Only CO2. See, only CO2. This is the initial state. So how much CO is there? Zero. How much O2? Zero. But rice table again, they're always in molarity or pressures. Always in molarity. Do not do this error in the exam. Like here they have given me 1 mole in 1 liter. So I'll calculate the molarity of CO2. Always in molarity when you are working with Kc. This Kc. C means concentration. Or they are always in pressures when you are working with Kp. Correct? And the unit of pressure generally you are going to take atm. Okay, so rice tables are never in terms of moles or grams, never ever. They're always in terms of molarity or pressures. So what's the concentration of CO2 here? Molarity, you know? Yes. Molarity is moles over volume. Big chemistry, unit 3, and it's there in unit 2 also, I think. Unit 1 also. So it is 1 molar. This is initial. Now assume the change. Can you type here the change, children, in terms of x? You're going to take this coefficient in front of the x. No. Minus x plus x plus. See this coefficient, Sanvi? X over 2. Right? So what is there at the equilibrium? 1 minus x, x, x over 2. Sanvi, you have understood this? Avoid this error because 1 is going to give you half. If x amount is undergoing dissociation, then you are getting x over 2. But I don't know x. Where is x? I don't know. I need to calculate because they are asking me to calculate Kc, and Kc is concentration of this, which is x over 2 raised to power 1 over 2 times concentration of this over concentration of this. If I know x, I know Kc. So how should I know x? Is there any other information, children? Any other information? Yes, Lisha? Lisa? What does it mean? It means 17.6% of CO2 has undergone dissociation of CO2 is equal to X. It means that because X is the amount which has undergone dissociation. It's called a degree of dissociation, percent dissociation. Very important questions are there based on it in acids and bases. So 17.6 times what is the concentration of CO2? 1 molar, see, divided by 100 is X. Or you can use this equation that percent dissociation is X divided by initial concentration of CO, this initial, multiplied by 100%. You can use this equation. We are going to do this equation and it will be given to you in the examination that formula sheets. What? Oh no, dear. 1 mole of CO2 is giving you 1 mole of CO. 1 is giving you 1. If you take 2, you will get 2. So X is any one of them. I think you are not understanding this clearly, Sanvi. Children, please check the question asked by Sanvi. Don't you think that if I calculate X, that's the amount of CO2 which has undergone dissociation? Why should I add these two? This question has come from many students earlier also. Why should I add these two? Because I have to see that this X, this is the amount of X which has undergone dissociation. So if X, I'm calculating this X. I'm not calculating the sum of these two because one is going to decompose into two parts, right? Anyone else having this problem? We are calculating this X, not the sum of these two. So what is X, children? 0.176 units. What are the units? Arya, what are the units of X? Mm-hmm. Units of X. Yes, molarity. Only Sanvi is answering. Good. Plug in the values here. Or you do it here. 1 minus 0.176. This is 0.176. And this is 0.176 over 2. And plug in all the values here and get the value of K. Again, a very unique and different type of question on the rice tables. Here, they are asking to calculate K. They have given you the initial. See what all is given. Initial. This is initial. What else is given? X. This X is given. You have to calculate by using this equation. What are they asking? Kc. So when you're reading the question, very carefully check the information. Reaction given, initial amount, initial conditions are given, how much amount dissociated, the percent is given. So I know X then. Get the Kc. Is it okay? Okay, I'm not doing the mathematics. We have to do more questions. Ready for this question, children? This is a very different question. And again, very important. Read the question. Take few moments for reading the question. Okay, if the question is clear, do I need to make the rice table? How will I come to know how to start? Do I need to rice table? Which part of the question is asking you to make the rice table? The equilibrium condition is given. This one in 2-liter flask. Suddenly 0.15 mole of HI is added. If suddenly HI is added, then the system is non-equilibrium. It is Q now. What will be the concentration of all species when equilibrium is re-established? This particular line is telling me make rice stable. This line is telling me make rice stable because only then I can work out the equilibrium concentrations. So ready for the rice table again? So reaction given here, H2 gas plus I2 gas giving you 2HI gas. Initial, children, can you give me the initials here? In non-equilibrium, not in equilibrium. In non-equilibrium, how much is initial H2? 0.040. This one, is it okay? How much I2? 0.040. This is initial. We started with an equilibrium and then we added something. How much HI? Is it this? No. How much is HI? You added something. Now you have to include this also. So it is 0.32 plus 0.15. Can I add them like this? No. Sachana, no. These are moles. You divide by volume. You can add molarity into molarity. This is molarity. Get the molarity. Now this is molarity. Now add them. You're understanding your error, Sanjana? Don't worry. Don't say sorry. Because when we do, only then we can do errors. And if you do error, you learn better. Identify your errors before the exam. Otherwise, you'll do the same error in the exam. All of you are understanding this? That why I'm converting it into molarity? Now, you add these afan. Is it okay? And you are getting 0 point now. How much, Azuni? 395 molar. Plug in that value here. Is this system right now in equilibrium? Is this equilibrium? No. Get the value of Q. What's Q here? It's a non-equilibrium, right? Get the value of Q. Initial is always non-equilibrium. We have to check every time. Get the value of Q. How much we are getting? I'm getting 97.5. Yeah, 52. Compare this Q, children, with K. You can see K here. Compare Q and K. Which one is more? Yes, Lisa, which one is more? K or Q? Anzara, Afan, Azuni. Which one is more? Oh, no. Can you see the K value here? Yeah. K is equal to how much? 64. From the question. See from the question. So Q is greater than K. In which direction the equilibrium will shift? In which direction the equilibrium will shift for the change? Yes, what about rest of you, Ashwin? Ritika, your answers are not coming. What are you doing, all of you? Anyone? Q is greater than K. Q wants to become K. Q greater than K means products are more than expected. Products are more. Equilibrium will shift to decrease the product. It will shift to the left, not to right. What happened? Very one student, first student did error and everybody copied it. It's going to shift to the left. As it is, you can see that you are adding HI. HI is added in the previous equilibrium. So when you add HI, it will go in the direction to decrease the concentration of HI. It's going to shift to the left, children. Please understand this. Don't do these silly errors. Like one answered right, and I've seen that all of you copied it. Is it clear why it is shifting to the left? Ashwin, Arya, left. Okay. It will shift to the left. Q is greater than K. You added extra amount of the product. So many hints are there in the question. It's a real AP question. So if it is shifting to the left, what is the change? It's a very different question. Change is this will decrease. This will decrease. Right? Shifting to the left. So minus 2x, this one. I2 will increase plus x. Plus x. The coefficients will come here. This is decreasing, shifting to the left. So they will increase. What's the equilibrium? This one, 0.040 plus x. 0.040 plus x. 0.395 minus 2x. That's the equilibrium. Now I can plug in these values. This is equilibrium situation. This one. Now I can plug in this value in my Kc. The value of Kc is given to me 64, which is equal to 0.395 minus 2x squared divided by 0.040 plus x squared twice. This times this. So this has come twice. Mathematically, I don't require graphing calculator. I can just take the square root of everything, Azuni. See, you can avoid graphing calculator. The square root of complete expression. What is the square root of 64? 8. What is the square root of this number? 0.395 minus x. What is the square root of this? 0.040 plus x. You plug in your calculator or you do algebra. My advice is again, please start using your graphing calculator. You can straight away plug in this and get the value of x. Once you know x, then you know everything. You know this concentration. They are asking this. All species at equilibrium. So it means you can work out this, you can work out this, and you can work out this. Because you know x, so you can work out all these values. And that's the question. Is it clear, children? This one is okay. So I'm going to clear it now. The mathematical part I'm leaving. Okay. I think this is the, okay, before we start the molar solubility. Hmm. So let's do this question very fast. I will be helping you in reading the question. Temperature given, temperature given. Volume given, reaction given. When equilibrium is reached, there is still some carbon solid left. These are the results. Look at the results. Time 0, 2, 4, 6, 8, 10. Can you tell me around what time the equilibrium is achieved? Around what time the equilibrium is achieved? Yes, so this is the equilibrium state. And what is initial, children? Initial? This is initial. So let's make the rice table. C solid, CO2 gas in equilibrium with 2CO. This is reaction. Now read the question. You can write down the Kp expression, all of you. I'm leaving this part. Read this B part. Calculate the number of moles of CO2 initially placed in the container. So how did you started the experiment? How did we start? That initially there is only carbon solid and carbon dioxide. See? Solid carbon, carbon dioxide were placed in a rigid container. Very first line. So initially, what is the pressure of carbon dioxide? 5, 5 atm. This is CO2 pressure initially because at that time CO was 0 and this is solid. This one is solid. Can you see how you are taking information from the experimental data for the B part? But they are asking me that how many moles of CO2 were present initially. So what should I do, children? I know that initially there was only CO2 and its pressure is this. I know the pressure. I know the temperature. I know the volume. So don't you think that for this question, I can use the equation PV equals to nRT? What do you want to calculate? N, number of moles of CO2, which is equal to PV over RT. What is P? What is the pressure of CO2? 5. If you do error here, if you are unable to work out that initially when the time is 0, there was only CO2, and if you are unable to identify that this is the pressure of CO2 initially, you won't be able to do this question. Arya, you're understanding this? We cannot do B question if we are unable to understand that initially there was only CO2, rest all were 0. Solid, put a dash there. We are not interested in it. So after knowing that, I know the pressure, I know the volume, I know the temperature, I know the ideal gas equation. It will be given to you also. What's the pressure here? 2.00, right? What's the volume? 2 liters. Oh, sorry. I did error, children. What's the pressure? Pressure is 5 atm. How many significant figures? 3. And this is the only measured value. This is measured, this is measured. You have to take care of significant figures. 3, 3. This is also 3. So 5.00 times volume is 2.00. R is 0.0821. Don't worry about sig fig of R. R is a constant. Temperature 1160. And you will get your answer with what are the units here, Arya? The answer will be in which units? What are you calculating? You're calculating moles. And you'll see that the answer will be in moles. Yes. This is how you're going to do the B part. Is it okay? Now let's do the C part. Read it very carefully and tell me, what are they saying here? What you have understood? Change, equilibrium. Let's complete the rice table now. It is in terms of pressures. So this is solid. So I say X amount of CO2 has undergone dissociation, X. So how much CO formed? 2X. Can you see this coefficient? 1 is giving you 2, X will give you 2X. Equilibrium, I'm not interested in solid. This one is 5.00 minus X. And this one is 2X. What is given in this part? They are saying that the partial pressure of CO2 at equilibrium is this and this. It means you know this value. What is it? 5.00 minus X is given to me as 1.63. So what is X? 5.00 minus 1.63. How much is this? Can you work out X? 3.37 atm. So now what is the partial pressure of CO then? What is partial pressure of CO? Partial pressure of CO is 2x. Means you multiply this number by 2. And there is one more way of solving this question. One more way. Anyone else? One more way. Is P total given? At equilibrium, P total. What is P total at equilibrium? Look at the table. 8.37, which is equal to partial pressure of CO2 plus partial pressure of CO. Partial pressure of CO2 is given to you. How much is that? Is given 1.63 here. 1.63. So can you use this Dalton's law of partial pressure to calculate the partial pressure of CO at equilibrium? Are you getting the same answer? Can you check it, children? Are we getting the same answer, Azuni? So there are two ways of solving it. You can use Rice table or you can use this P total equation because they have given you P total here in the table, total pressure. Ashwin, is it clear? So children, you are not asking any questions. So shall I take it that you are understanding everything? So there is no question from anyone. Afan, everything is clear? Ariba, Sanjana, your answers are not coming now. So good. Okay, are we done with the this part? Now can we do the next? Now they are asking me to calculate Kp. So you know the Kp expression for this equation which is written there here. What is Kp expression? I need some space, so I'm going to put a box here because we have done this part. We are doing the C part. So what is Kp? Kp is partial pressure of CO raised to power 2. Kp, Sanvi. Partial pressure of CO raised to power 2 divided by partial pressure of CO2. You know, children, these review classes are for 2 hours. Azuni, please put your question in the direct chat, in the general chat so that everybody can see. I can answer your questions when they are in the general chat so that everybody should understand what I'm answering and what I'm talking about. It is for 2 hours, so 10 more minutes to go, Azuni. Okay. So plug in the values here. What are the values? Equilibrium values. You know X. So what is the equilibrium pressure? This 2X. We calculated it. 6 point. What are the values? 6.74. And what is this value given to us? It was here 1.63. Plug in these values here. 6.74 squared over 1.63. And that's the KP value. It's a real AP question, children. It's a real AP question. I think it was in 2008 exam. Somewhere 2008 or 2010, somewhere. And you can see it's a simple question, though it's very lengthy. But I hope you are understanding how we are going step by step. Now let's see the D part. If a suitable solid catalyst were added in the reaction vessel, would the final total pressure of the gases at equilibrium will be greater, less? Oh, very good question. Can you answer this? So when you add a catalyst, will the pressure changes? Final pressure, equilibrium pressures. Will that change? So when you add a catalyst, do you think the Kp will change? No, Kp will not change because the reaction will go equally faster in both the direction. This is your without catalyst and this one is with catalyst. So the rate of reaction is equally becoming faster in both the direction. So will the partial pressure going to change of these gases? No, no change. No shifting, no change. Can you see this catalyst question? The Chatelier principle. Justify your answer. Justify your answer by these graphs. Make this catalyst without catalyst graph. Energy profile, the way I explained you earlier. Make this energy profile. Explain the rate of reaction is increasing equally in both the directions. So the amount of CO and CO2 present at the time of equilibrium will not change because if it goes more in the direction of CO, exactly in the same way with the same factor, it will go more in the direction of CO2. So they will not change. Is it okay? Can we do this part now? This one. I'm going to clear it because now we don't require all these things. Now we are on this part. E part, last part of the question. Ready, children? So I'm writing the equation here. Read the question and tell me, do I need rice table? Do I need rice table to answer this question? Okay, Sanvi is saying yes, and she's right because they are asking me to predict in which direction the equilibrium will shift. And they have given me a non-equilibrium state, means initial. Initial is non-equilibrium. And from here, I'm going to calculate Q. And then I'm going to compare my Q with Kp. And then only I can answer this part. So I don't require the complete rice table. I need reaction and initial. So initial 10 gram of solid. Are you interested in this solid, children? Are you interested? No. Just put a dash. Initial is 2 atm. This and this is also 2 atm. See here. So what is QP? Pressure of CO raised to power 2 over pressure of CO2. How much is that? 2 squared over 2 is 2. What was the KP we calculated here? I didn't calculate. Do you remember the KP, children? KP is, I think it was 6.74 squared over 1.63. Can you check this? How much is this? Sanjana? Yes, Sanjana. I think I'm getting 27.98. Children, check it. 27.86. I'm getting this. Anzara, can you check the calculation? So maybe I've taken something here different. It's okay. Is this KP? Now compare this KP with this QP. So KP is greater than QP. KP is greater than QP, right, children? Okay, your turn now. If KP is greater than QP, please don't see the answer given by other students. Try to answer this on your own. KP is greater than QP, means QP is small. What does it mean? Reactants are more or products are more if QP is small? QP is the same thing. So what is more? The reactants are more. So in which direction the equilibrium will shift? Yes, now it will going to shift in the right direction. Yes, Ashwin. Good. Good children. Arya, your answer? Arya, your understanding? Fine. Okay, good. So now answer this question. Predict whether the partial pressure of CO2 will increase or decrease or remain the same. Yes. What will happen to the partial pressure of CO2 when it is shifting? The partial pressure of CO2 will increase, decrease, or will remain the same. Please write down. All of you write down. Ariba. Yeah, it will decrease because it is shifting to the right. Look at the Sanvi. She is giving me the reason also. Yes, Anzara. Yes, Ariba. Good. Perfect. Okay. So can you see that this is a big question and we have done it so nicely. And here you have used the concept of Dalton's law of partial pressure also. Okay. Now the next concept is KSP or molar solubility. Children, the things are going slightly slow, but definitely we are going to pick up the pace and don't worry, I'll give you extra time. You will get the good and very refined review of everything. Okay. So I was expecting to finish everything in 2 hours, but it's becoming slightly difficult. So we'll continue in the next class, right? And if you have any questions, you can stay back.